Good afternoon, everybody. Thank you for being here. Today we will speak about gamma radiation, but used for the preservation of cultural heritage with the help of Dr. Alessia Cemmi. So first of all, thank you very much, Alessia, for accepting our invitation. Dr. Alessia Cemmi works at ENEA. ENEA is the Italian National Agency for New Technologies, Energy and Sustainable Economic Development. And in particular, in this agency, she is currently the head of the Innovative Nuclear System Laboratory and director of the Calliope facility. The Calliope facility is a gamma radiation facility dedicated to testing, qualification, and characterization of materials, but also components and devices for different applications, space, nuclear industry, and other kind of application. I know that you are involved in this research field for several years, and you have established a lot of international collaboration through your work in European projects and other projects coordinated by the International Atomic Energy Agency. Yes. So I would like to give you the floor for this presentation, and at the end we have some time for some question or comments. Okay, so the floor is yours.
Yes, thank you, Elena, and thank you for giving me this opportunity to share also my work with you and my latest results. I share screen.
Remember to include.
Yes, is it okay? Okay, you can see it. Okay.
Yeah.
Okay, so starting with my presentation today, I would show you some pictures here that you can see, and I would ask what for you this picture are in common, and this is an example of application in different fields, as you can see here, of gamma radiation. And in particular, gamma radiation can be used, and I'm sure that most of you are familiar with this application, are used, for example, for the production or the processing, so for also industrial application and for different kinds of application, as you can see here. But gamma radiation are also used, to test the characteristic and the resistance and the hardness of material that during their life have to be exposed to radiation, such as, for example, material for space or, for example, for nuclear plants or application, of course. But probably not all of you know that this kind of radiation can be also used for cultural heritage. And this is exactly the topic of my today's presentation. So, outlining my talk, first of all, I give you just some of the most important features of gamma radiation for this kind of application. And then I would talk and describe which is the international situation for this kind of application, and also the different from Italian side, because you'll see that Italy is not exactly as the other European and ex-European countries. In the second part, I would show some of the results of our past or present results. And in particular, in the last part of the presentation, I'll show you also some case study, some real activity that we are performing now, also in the frame of a different project, as you'll see. So starting with the first part, okay. Usually, ionizing radiation can be used for cultural heritage for three different purposes. The first one is the use of this kind of radiation and also other kind of radiation as diagnostic methods. So for the analysis here, for example, I show you just some of the example. And there is no problem for this kind of use from the cultural heritage operator and restorer, because it's well-assessed activities. Then there is other two applications. The second one is related to the use of ionizing radiation for the consolidation and protection, in particular of porous material, for example, artifact made of stone or, for example, wood, that are damaged because, for example, as you can see also in this picture, you can find this for example, wood material in the, for example, river. Also, in this case, the wood is completely impregnated by water and so is damaged. And with the consolidation and protection, you can substitute the water that is inside the wooden structure, for example, and replace it by a polymeric material. And it's possible to perform the reticulation, so the consolidation of the material under irradiation. But then I'll see you also later a short video about these particular activities. And the last application is the use of radiation for consolidation and protection and preservation, of course. And in particular, these activities refer to the use of radiation to eliminate all the biodeteriogen agents, such as, for example, insects, molds, fungi, or the spores of the fungi, that can damage the material. Usually, this kind of biodeteriogen attack the artifact and the cultural heritage made of natural origin material. So, for example, wood, paper, and parchment, and so on. And another very important aspect is that very often this kind of microorganisms are also harmful, not only for the artifact itself, but also for the operator and the people that can be in contact with this artifact. So it's very important also for the health of cultural heritage, for example, operators or restorer and so on. And in my presentation, I focus my attention on this third kind of application in particular. So let's see some of the most important characteristics of gamma radiation that you know, of course, that are characterized by very high energy, of course. And there are also, of course, gamma radiation produced by natural, for example, cosmic ray, or also by the decay of some radioactive nuclei. In particular, usually in the irradiation plants, you can find cobalt-60 or cesium-137 as radionuclides that for the use of the production of gamma radiation. Gamma radiation have a very important characteristic that is represented by high penetration power, so respect also to other kind of radiation, but of course you know it. But why this is so important for the application in cultural heritage? Because, for example, due to this high penetration power, it's possible to treat simultaneously an object not only on the surface, but also in the bulk. So, for example, it's possible to eliminate, I don't know, insect or molds that can damage and attack all the artifact. Is also very important because differently, for example, from the treatment with electron or partially with X-ray, there is no need to eliminate and to remove the packaging of the artifact. So it's very important also for the cultural heritage operator because you don't have to handle directly for example, precious artifact. It's possible also to treat or large amount of artifact or artifact of high volume, for example, and also it's possible also to treat the artifact made of different material. And in particular, you know that also gamma radiation can interact in different way with matter. And the main processes are, of course, using gamma radiation, for example, by cobalt-60, the excitation and ionization. And of course, you know, but it's very important also to repeat this aspect is that by, for example, gamma radiation of the energy of cobalt-60, so around 1.25 MeV, no radiation can be induced in any kind of material. So it's very important because it's immediately the material immediately available also after the treatment. But the treatment by gamma radiation represents also several advantages over also the technical method that usually also in the past were applied to the removal of biodeteriogen. In particular, this traditional method implied the use of chemicals, for example, or physical process. So, for example, they imply the use of microwave or heat and freeze drying process, or, for example, toxic gases, especially for the removal of insects. But the gamma radiation present, as I told you, several advantages that you can see here in this yellow part. And for example, it's not necessary to directly use for example, toxic chemicals. It's not necessary to add it when you treat by gamma radiation. And so also the artifact is really available after the treatment, as I told before. And also another very important aspect is that also in porous material, no toxic or harmful residue remain inside the material. And this is a different, for example, from the treatment with gases, for example, ethylene oxide that was used a lot in the past that remain inside the material, of course. Then another very important advantage is represented that the fact that this is a procedure, the treatment that occur at room temperature, so there aren't unwanted increase or specific increase of temperature in some part of the object. And this is another different, consider the treatment, for example, with electrons that can increase the temperature due to the very high dose rate, for example. Is also a quick process, because if you think that in around 2 or 3 hours, you can treat also a large amount of artifact, of material. And another, finally, the final statement is also very important, because different from the other method that are, for example, I don't know, also some chemicals are specific for one mold, but not for insect or not for other molds. The gamma radiation have the lethal effect, so on all the microorganisms at the same time. And then I'll show you why. So it's very important because you can eliminate at the same time insect, but also, for example, the spore of the fungi that are very harmful. But due to the interaction with matter, of course, gamma radiation can also induce some unwanted effect on the material that are called side or secondary effects. And this kind of effect present different characteristics. For example, of course, they depend on the material. They can also irreversible, so it's not possible to remove them, for example, or recover the material in this sense. This kind of modification can occur during or after the end of irradiation, and then I'll give you some more detail about this. And it's also very important that it's possible measure this kind of modification by means of different analytical techniques. And finally, very important is that depending on the parameter that we choose during the irradiation, it's possible to limit or to minimize the secondary effect. This is very important for this, in particular for this kind of application, because of course, very often you can have to treat very precious and practically unique object, for example. Another important thing is that the modification induced by radiation, usually that consists in, for example, depolymerization, oxidation, yellowing, are the same that are induced by also other agents. For example, the natural aging of the object, or also the occurrence of the natural or anthropic disasters such as floods or, for example, war. And also due also to bad storage condition. If you can imagine, a lot of different, for example, also library are not so in a precise and good condition in terms of humidity or light and so on. And another thing that you have to keep in mind for the treatment of cultural heritage is very important to decide case by case if it's necessary or not to perform the treatment, because in any case, for any kind of treatment, not also for the processing with radiation, some changes or modification could occur inside the material. But the alternative very often is completely the loss of the artifact. So you have to decide, and if case by case, if it's necessary or not to perform some kind of treatment. Now, back to the effect of radiation, I will just here give you some more detail about the direct and the indirect effect. The direct effect usually occur directly under irradiation, and they can be influenced by the choice of the irradiation parameters. For example, in terms of dose, or the absorbed dose or dose rates. Also on the environmental atmosphere in which you perform the irradiation, because it's possible, of course, perform the irradiation in air, so at room condition, or also keeping the artifact in inert gases, for example, and depends also, of course, on the composition mainly of the material. But then there are other indirect effects that can occur after the end of irradiation. And these kind of effects are due to the presence and the creation under irradiation of free radical species that, of course, are very, very reactive. And these free radicals can also react with the oxygen of air and create very important and very reactive different kind of radicals, also containing oxygen. They're the most important because are related mostly to the oxidation of the material. Considering the effect on biological system, gamma radiation can induce damages at the DNA level, or, for example, on the cellular membrane, or, for example, also protein denaturation, of course. So for this reason, the effect of the gamma radiation is indiscriminate, depending on the different kind of organisms, microorganisms. So the damage is the same on insect, but also on fungi, for example. And this is very important. And now, just to have some more idea of the most important effect of material, here I would just show the most important process that can occur, and that can be very important related to the application in cultural heritage. The first two effects is the cross-linking and the polymerization. So during the radiation, of course, depending on the condition, in this case, as you can see, at low dose, the cross-linking process prevails. But if you increase the dose, you have more depolymerization, because both the processes are always in competition. And so at low dose, the predominant effect is the creation of new bonding, chemical bonds, while with the increase of the dose, usually the effect is the breaking of this dose. So also, for example, you have the breaking of the chain of the polymeric chain, for example, of the cellulose, that is a natural polymer. Another very important effect is the oxidation. that occur, of course, during the irradiation in presence of oxygen, of course. And a particular kind of oxidation is the degradative oxidation, because if you keep the radiation in air, the oxygen can diffuse inside the thickness of the material that you irradiate. And the part interested by the diffusion of the oxygen is that it is interested by the degradation. So if you want to decrease or minimize this phenomenon, it's possible to, for example, perform the irradiation without air, so for example in inner gas atmosphere, or it's possible also to reduce the time of exposition of the material to the action of oxygen during the irradiation. So, for example, reducing the irradiation time by increasing the dose rate. All these effects can increase the concern of cultural heritage operator, of course, for the treatment of cultural heritage artifacts, because can be responsible of, for example, embrittlement or color changes, as you can see in the bottom part of the images. So, for example, the yellowing of paper, for example. But it's very important to remember that, of course, all these processes can occur, but depends on the irradiation condition that you decide to use. So it's really possible to practically limit completely this kind of phenomenon. So I would describe which is the situation in Europe and also in some other ex-European countries about this kind of application. And a lot of work and is done by the International Atomic Energy Agency, of course, that organized also in the past, but also now is starting another of this kind of project, organized a lot of research, and by means of the coordinated research project. For example, in the last project that ended 2 years ago, more than 20 countries participate. This is very important because in this way it's possible to have a multidisciplinarity in the research, and it is very important in this kind of application, because you need to know also the problem presented from, for example, cultural heritage operator, but also the expertise of chemical physics or engineer, for example, and also, for example, by the biologist. A lot of the past results were also collected and published in a different IAEA document that you can see also on the website, but a lot of ongoing activity are performed regarding in particular the secondary effect and the stability, so the permanence over time of the irradiated material. And this is very important because with this work, I would also to define really share guidelines to be followed worldwide, and what is defined in the past is a very important point that I show here, because was defined usually the maximum absorbed dose that you have to use on cultural heritage material to remove the biodeteriogens, but to avoid the damaging of the material due to radiation. And so the maximum dose rate is 10 kilograms, 8 plus minus 2. And depending on the kind also of biodeteriogen presence, you can choose and limit this value. It's very important to keep in mind that you always have to try to minimize the treatment, also, for example, the absorbed dose. So, for example, if you have just insect on the particular artifact, it's not necessary to increase to the maximum value the absorbed dose, but less than 2 kilograms are enough to kill usually all the insect present. So is very important to keep in mind this point. Why in some cases you need to use so high dose? Because there are some microorganisms, in particular the spores of the fungi, that are really very resistant. For example, also with other traditional methods, you can, for example, be able to eliminate fungi or molds, but very often not the spores of the fungi. So again, they can create a new colonization. Now I would show you some of the example of the results and the activity of our colleague from different countries, and I will start with the experience of our colleague from Brazil. And they prepared this very nice and very short video that I would show with IAA. That is very important because very often people that work on cultural heritage field do not know which is the possibility and offered by the treatment by radiation, and sometimes they have some concern about this. So it's very important also to the diffusion of this kind of technique. So I try to start with the video, and I hope that sorry. Okay. And continuing with the presentation of the activity of the other colleague, here I show some treatment of a different kind of object, as you can see here, really very different also from the Brazilian ones, made from the Croatian and Romanian colleagues that use this kind of techniques a long time, around 30 years. And very often they have to treat also ethnographic object, as you can see here. So made, for example, also of wool or other tissue, particular tissue. And one of the most important example of the application and the activity of the the Croatian colleagues is the restoration, the treatment of a wooden panel in this chapel, St. Martin's Chapel in Stary Brod. And that was also awarded by a European Conservation Award. And here I show you the picture of the internal part of this chapel that was, as you can see here, completely destroyed and attacked by mold and fungi. So all the panels were dismantled and treated in the radiation plant of the Ruđer Bošković Institute in Zagreb. And then after the treatment, with the elimination of all the biodeteriogen, the panel was restored by the restorer, and this is the results, the final results. So you can see, which is is a really stunning example of the conservation and preservation treatment. And finally, another very interesting example that I told you before that I show you is related to the conservation, mainly conservation activities performed at the Art Nuclear, that is a laboratory inside the CIA at Grenoble. And this colleague have a irradiation plant, a gamma irradiation plant, and all the laboratory is dedicated to the treatment of cultural heritage. So I would show another short video about their activity that is very, very interesting. And they worked in this field for more than 50 years. So let's see. Okay. As you can see, they treated a really very important also art piece and ancient piece, for example, the Ramses mummy that you saw before. And here you can see more about this. Yes. This is the director of the laboratory, and they work a lot on the waterlogged wooden, also from the ancient Roman boat, or for example, the painted wooden statue and so on. Yes, also Gallic Roman ancient material and artifact. And this is a part of the boat that they found on the bottom of the river, the French river. And this process of the consolidation is really very long and very, very expensive. You have to consider that, for example, to treat one of these boats, sometimes it takes years. So, and with a very high expenses. But is of course very important that in the same place where the irradiation plant is, there are also a group of restorers, for example, that can help and work together with, yes, here is Lorana, our colleague, with the physicists, for example, the technician that that perform the irradiation. This is the pool for the storage of the gamma radiation source that you can see here. And so you can see also, yes, this part of the facility. And they have also this very, very huge pool full of the polymeric mixture that they use for the consolidation, because also the impregnation process is very, very long. And so, yes, you see here, for example, which is the dimension also of the object that they have to treat. And some of these wooden, yes, in this case, this wooden boat is then exposed to the museum, National Museum. Okay, I think that is finished. Okay, but also on the web, you can find a lot of material about this if you are interested. Let's now turn into the Italian situation. In Italy, as you probably know, when you talk about radiation, there are a lot of prejudice or lack of course, of correct information, and in some cases, some fear about radiation. But it's very important from our side to try to fill this this gap between the correct information and from the from the side of a scientist. This is very, very important, in my opinion, for all the application of nuclear in a different field. But considering the cultural heritage, the radiation are used just for diagnostic method that is completely accepted. And up to now is the treatment with radiation for the preservation purposes is not applied, but something is changing, and I'm very happy for this. And then in the last part of the presentation, you'll see why. So just some activities was performed also in our laboratory as research. But for this, it's very important to try to produce a lot of and reliable scientific data about this kind of application, but focusing also on the possibility to have this unwanted secondary effect, and to demonstrate that if correctly applied, this kind of treatment is completely acceptable, because no modification are induced on material. But it's important to produce a lot of scientific data about this. There is still necessary. Why is very important? And what can we do in this sense? Here I would just describe our irradiation plant. You saw the irradiation plant of CIA, of the arc nuclear before, and these two plants are completely different, because the source, of course, is the same, because we have, of course, a cobalt-60 source, gamma radiation, gamma radioactive source. But the main difference is, as you can see here, the dimension of the irradiation cell. Because Calliope facility is unique in Italy and also in Europe due to the high dimension of the irradiation cell. So it's a research plant, but with a very huge irradiation cell. Why this is so important? Because in this way it's possible, for example, to perform several irradiation at the same time, or also it's possible to irradiate a big object. This is very important too. Also in our plants, we can perform irradiation in different conditions of atmosphere, temperature, and so on. Also, we work, for example, also for space, as Elena told before, for the qualification of electronic components, for example. So it's necessary to put to perform the irradiation under bias. So we can perform different kind of way during in the different condition during the radiation. In this picture, you can see here in the center a plain source with a 25 cobalt-60 source, and this is a pool type irradiation facility. Below this rack that you can see, there is a 8-meter high pool, and filled with water that represent the biological shielding of the radiation during not during the radiation, but when you have to enter in the cell to position the samples, of course. And the maximum dose rate now is around 7.3 kilograms per hour, so is high. Our facility is also characterized by the presence of a dosimetric laboratory, in which we can perform directly real dosimetric measurement. We have also the simulation of the absorbed dose inside the cell, but very often we do perform directly the dosimetric, experimentally the dosimetric measurement with different system. We, for this reason, can also perform the service for external users, and we can release also the certification for the irradiation and the dosimetric measurement. And we have done a characterization laboratory, mainly focused on, of course, on the characterization of the modification induced by radiation on the material. So we have different spectroscopic and optical analysis, as you can see here. We have also an electron spin resonance spectrometer that allow to study the formation and the behavior of the free radicals during and after the radiation. And then we can also perform accelerating aging tests by means of different systems, for example, climatic chamber, as you can see here. And also this is very important because it's possible to study the and to have a prevision of the behavior of the material also during time after radiation, or if you keep the material in a particular condition in terms of temperature, humidity, or presence of, for example, also UV light. What is the most important material that we studied in the past, and also we are continuing to study is the paper. Why? Because the paper is the most common, of course, but also the most fragile material that constitute a lot of material of cultural heritage interest. For example, thank you to books or other kind of material. And for this reason, is also very important to find, due to the high variability of the condition of the paper that you can find, to define a material of reference. In this way, you can exactly study also the modification and the changes induced by radiation in the material without other interference, for example, from environmental condition or aging of the material itself. So we decided to consider as a reference material the Wattmann paper that is made of pure cellulose. And here, of course, you can, but I know, of course, that you know, you can see some SEM images with the fiber of cellulose, and at the microscopic level, they are formed by a chain of glucosidic ring connected by glucosidic bond, of course, as you can see here. And these different chains are then connected, bonded by hydrogen, usually bonding, intermolecular bonding. And the network of the cellulose is also formed by the presence of water in different form. So you can find little drops or some molecules that produce also the hydrogen bonding to connect the different chains of the cellulose, but you can also find the water absorbed on the surface of the cellulose. In our laboratory in the past, also, we focus our attention on three different aspects of the relation of the gamma radiation and paper for cultural heritage. So in this range of those that you can see here. The first one, and that was the first was studied in the past, was to assess the effectiveness of the gamma radiation to eliminate the biodeuteriogen, and also to investigate the effect of the environmental effect on this kind of process. Also checking if the treated material, the irradiated material, will be then easily or less easily attacked for further, for example, attack from insect after the treatment. A second part was related to the interaction between cellulose and water, also during irradiation and also during the modification induced by radiation. so the cross-linking and degradation, as I told you before. And the third one, that is the aspect that we are performing and we are planning to perform our next activity, is also related to the study of the stability over time of the material, so the permanence of the paper, for example, during the storage, conservation, or before and after also the treatment. And we use different experimental technique, as you can see here. And we decided to use preferably, of course, the technique that are for in situ or ex situ analysis, but not invasive and not destructive, of course, because this is very important for this kind of application. And we also try to use techniques that are easily found also in different laboratories. I know that not all of these are have this characteristic, but in fact, we find that the best one in this sense could be, for example, the infrared spectroscopy and the colorimetric analysis, that are very important for the study of material, cellulose-based material, of course, and then I'll show you why. So here I just would show some of the other all the results. And this is regard the first aspect that I described you, so the biological effect on different material, as you can see here, and also was investigated the effect on the environmental atmosphere, but I described you before this. And for example, also photographic paper and inks are investigated. And so this is a real reference work that is done by a colleague that was in our laboratory. Now she's retired. A second part regard, just as an example, the use of infrared spectroscopy for the study of paper. Here I reported just infrared spectra. I don't know if some of you are familiar, more or less familiar with this, but just to have an idea of the amount of information that we can obtain by this kind of spectroscopy. There is mainly three different ranges that are important for us. The first one in red is related to the most important process, that is the degradation of the material. So, for example, the oxidation with the formation of CO bonding, that are mainly related to the also modification in color of the material. And then the other two are related to the formation or the breaking of the material, so the cross-linking or degradation. And okay. And this is, for example, a study that we performed, studying the effect of gamma radiation also reaching very high absorbed dose value. And we defined that below 10 kilogray, of course, the cross-linking is the process that is predominant. And this is very important for the application on cultural heritage, of course, because the degradation occurs just if you increase the absorbed dose. So we have to avoid this. And here we studied also the interaction with water, but I don't want to describe this. Another one of the our last research regarded the effect also on oxidation of the irradiation parameter. In this case, we studied the Wattmann paper and the oxidation measured by FTIR at a different dose and in the range suggested for the treatment of cultural heritage, but also a different dose rate. In this case, you can see, especially in this part, that depending on the dose rate, so the rate of the irradiation, you can decrease absolutely the oxidation of the paper. And so it's very important. So in this case, you can minimize this effect. Considering this is the same plot of the slide before, considering the worst results, that is in the point in this red circle, we tried also to analyze the modification in terms of color. So we use the C lab reference measurements. And as you can see here, there is a complete practically overlapping of the point related to the not irradiated and irradiated paper. There is this parameter delta E star that is related to the perceptibility of the change of color for the human eyes, and the measure of this parameter is absolutely below the perceptible, visually perceptible light variation from the human eyes. So there is no modification in color. And so let's talk now about the last part of the presentation. So I show you some case study in which we are involved now. The first one regards the treatment of this huge number of books of different period that are at the law department of the La Sapienza University of Rome, and they are damaged by the humidity and the bad storage condition which they are kept also in the past, and they are also attacked by the different fungi that you can see in the black part of this book. During a work of PhD student, they are studied in terms of the state of the health state of the fibers and all the different part of this book, and also the iron gallic that is present was analyzed. Then also after sampling on the same book, as you can see on the right side, here there is the growth of the microbial community that are present on this kind of book. Before treating them with the radiation to check the effectiveness of the elimination of this biodeuteriogen, the same biodeuteriogen are treated by different chemicals that are traditionally used for the removal of the fungi. Some of these are also not allowed now, but they tried in any case. But as you can see here, there isn't a complete effect of elimination of these kind of molds. We treated this same microbiological community, and we found that some of them are eliminated, completely eliminated at 5 kilogray, while just the black fungi, that is the most resistant, is eliminated at 10 kilogray. So, of course, we have preliminary results that is very important for the treatment of this kind of book. But what I want to describe now is the project that we won last year, and is a project of our region, Lazio region, that is the region of Rome, of the Excellence Center of Lazio region. And the Pergamo project deals with the application that is the focus of our presentation. We have different stakeholders and partners, of course, and this is very important. This is very important because for the first time in Italy, real artifact will be treated. So we are also very proud and very happy of this. Here there is just some information about the project. We intend to treat different kind of artifacts and of the different stakeholders, not only by gamma radiation, but also by electron and X-ray. And the final aim of the project is to create a service for the treatment and the characterization in situ and ex situ with not destructive techniques for the treatment of the cultural heritage artifact or material that are of interest. And also it's very important for us to arrive to define a protocol for the treatment of this material. So just an example, we have also a company that work with us that work on the not destructive analysis, but that can be performed in situ. That is very important for the operator. And here we have some of the stakeholders, for example, Appia Antica Archaeological Park, that is in Rome, of course, and the artifact, also some statue, are attacked by the lichens that, as you can see here, can modify the color, for example, or the stone or the statue, but also responsible for the detachment of some part of the material. So it's very important to investigate, and also this is the first time to investigate the radio resistance of this kind of microorganism. The same problem is also in the Mozia Island, that is a little island Phoenician, is an ancient Phoenician colony that is in Sicily. And also here you can see there are a lot of colonization of black and also yellow lichens. But what is very important for us is also the collaboration with the Monte Cassino Abbey. That is a very, very important abbey, because they have a real library of national and international value. And they supply us some of ancient paper, and for here just some example of them, parchment or paper. There are some fragments that we can treat during the program. These activities were planned for the next months of the next year. And in this, after summer, we dedicated our attention on the treatment of these two books that came from a library of the Croatian colleagues that are stakeholders of the project. And as you can see, especially on the book 2 on the right side, they are colonized by different microbes community. So we sampled in different part of the book these books, and this is the growth of the microorganism after 3 or 7 days in both the books. As you can see, we have a mixing of the colony. So the same book are irradiated, and at the Ruđer Bošković Institute with the plant of our colleague at 2 different absorbed dose. And as you can see, there is an effect of the absorbed dose on the growth of fungi. So for kilograde, the first for picture demonstrate that is not enough to the removal of all the microorganisms, while if you increase the dose at 8 kilograde, you have practically complete removal of the colony. You have just 2 colonies that you can see in these petri dishes. Then we repeated the same irradiation at the Calliope facility. We repeated the irradiation at the dose rate of 130 gray per hour that performed at Ruđer Bošković Institute, but we tried also to repeat the same irradiation at the higher absorbed dose, 1,500 gray per hour. And this is the results. So at 8 kilogray, we observed the same results obtained by Ruđer Bošković, because in one book there is the elimination of the mold, but not for the other. But if we increase the dose rate, we observe the completely removal of the microorganisms also in the other book. And this is very important because, as I told you before, the correct choice of the radiation parameter is a fundamental aspect. And on the same book, we performed also some characterization of the material. In particular, we studied the oxidation state. And we report in this plot also the data that I showed you before related to our reference material, that is the Wattmann paper. And differently from the book, as you can see, for Wattmann paper, there is an increase of the oxidation during the irradiation with the increase of the absorbed dose. The other 2 books as you can see, practically are not modified by radiation. So the value of oxidation state before the irradiation, so the blue bar, is exactly the same after irradiation. And this is very important because the oxidation state seems to represent a protection toward the effect of irradiation. And another very interesting thing is that if you consider just the two old books, one, so the first one, that in the center, is more oxidized than the other. And effectively, also the color of the pages, also before irradiation, was more yellow than the other. And on the same way, we perform the measure of the color, eventually change of color of on the two books. And also in this case, you observe that, as I show you in the previous slide, the Wattman paper, of course, is white, completely white. We have the book 2, that was on the right side in the previous slide, was more yellow, but the book 1 is even more yellow than this one. So we observe a different in coloration due to the different oxidation state before irradiation, but also is completely the same also after the irradiation, because the point that you can distinguish here are related to the measure before and after irradiation and are completely overlapped. So there is no modification, no visual modification in terms of color during the irradiation and after the irradiation. So in conclusion, of course, ionizing radiation can be successfully applied for the removal of bioburden, biodeteriogen from cultural heritage material of different composition. Is very important for us the correct choice of the irradiation parameter in order to limit and to minimize of the secondary, the side effect that can occur in a different material if not correctly applied the irradiation process. And it's also important to define some reference material to investigate really the single effect of the one factor, that is the irradiation, in the way that is possible to separate the effect of irradiation, for example, of the bed storing condition and so on. And another interesting aspect is the possibility to perform, for example, accelerating agent test to investigate and to assess the behavior of the material also during time or if stored in bad condition, not only subjected just to gamma radiation. And I would thank you for your attention. And if you have any question, I'm very happy to answer. Thank you.
Thank you, Alessia. Thank you really for this interesting presentation, full of picture examples and also the video, because it's not so easy for us that maybe other kind of works and so on to have a clear idea of
yes.
this kind of.
I hope that I'm not trying to be.
No. I think your presentation was very clear in clearly explain what is behind the treatment with the interaction interaction with the metal, and also to clarify us what are the main point in this kind of.
Yes, also the issue and.
Yes, in this kind of. I understood that the setup of this procedure is paramount, and you have to do that on reference material that.
Yes, it's a long work because also the aging treatment it takes a lot of time. But yes, we began also before the COVID, but then we stopped, and. It's also important to follow the material that you treat in the aging, for the aging, also for a month or year after the treatment. Aging, the treatment. So yes, it's very important also this. But I think that could be a very important point to convince also the cultural heritage operator that these techniques can be, of course, absolutely applied without particular problem.
Yeah, I think to reach a good result, you need to work in strict collaboration with all these.
This is very important because also in our activities is necessary to work with physicists, chemists, and microbiologists, because it's a really multidisciplinary activity, of course.
Yeah, of course we have few minutes for some questions. So if the audience, someone would like to ask something or comments, some part, please feel free to open the microphone and ask. In case there is a question in the chat from Ekaterina, I can read it. So far, the research of gamma radiation on paper was made either on Whatman copy paper or on printed books. Do you know of any study of the effects of irradiation on manuscript with iron gallium ink?
Yes, some of the study were performed because I know iron gallic ink was used a lot in the past, and it seemed that it seemed to be resistant to this kind in this range of absorbed dose. Also, my colleague, I show you just some results about inks, and it's possible to apply this technique also for if you have this kind of ink inside the book, because of course the printed ink are more resistant, but the ancient was applied.
Thank you. If there are other questions.
Do you have any studies, any articles to recommend? Sorry, it's
please, Ekaterina.
Yeah. If you want, I can. I can send to Elena some paper. But also, if you look for it in the IAEA website, you find a lot of information. Okay. So and also a lot of books on paper or reference. But if you are interested, I can send to Elena some of this.
Thank you very much. Very, very kind.
Thank you. And I think that in your work, the collaboration with the International Atomic Energy Agency was very important to connect all your,
of course,
the laboratory like yours.
Yes, because
in order to work together.
Yes, since in each country very few people work on this, it's very important for us to share also our experience, and we are really complementary because also if you when I show you the video, for example, of the Brazilian colleague, they have a very big plant. And for example, also they do some research, but in some case, for example, we have some instrument that the other laboratory do not have. So very often we share also not only our experience, but also the samples to be measured in different laboratories. So it's very, very important for us. And also then we work together also for a regional project, for example, as in Bergamo, because two of these colleagues are stakeholders of our project, and the strength of this collaboration is very, very important. Also, if we then there is exchange of students, for example, is really, really very important.
Yeah, and I think you have also to deal with the rules that are present in each country that allow to perform some treatment or not, or to allow to use some chemicals or not.
Yes, of course. And also in terms of the application of radiation, for example, in Romania, they can use higher absorbed dose, for example, but we try is a different point of view, because yes, of course, I know that if you irradiate also at more than 10 kilogray or less precise than 10, you can kill all the microorganisms. But I don't know, probably in Italy also the cultural heritage community is more conservative, but in a good way, in my opinion, because these artifacts very often are unique. So it's very important to consider how to treat it.
Indeed, I think you are very brave people because you work on unique pieces, so you have a great responsibility.
Slowly, but we'll try it, yes, to work also more with this activity, also with the other users. But I found that the interest is growing because also of the fact that a lot of different chemicals are banned now. So it's important to find an alternative techniques. Yes.
Yeah. And what about the use of other kind of ionizing radiation?
Yeah, the main difference, the process are the same. The interaction with matter, so electron and X-ray give the same results. But the main difference, the most important difference is the penetration power. So, for example, if you use electrons, is very easy sometimes because you can also bring with you some, in some way, this kind of technique, but the penetration is very low. So it's okay if you have to treat, for example, a sheet of paper, a parchment, but if you have a book, is not good because you have to treat in several times, for example, and also you have an area that is limited, that is in which we can try treat the book. Gamma radiation is easier and very useful in this case because you can treat also, for example, also big volume or amount, big amount of books, also without removing the packaging and so on. Yeah, this is the main differences, of course. And of course, in the radiation plant, you have to bring to our lab the artifact that you want to treat. But for example, also in the video of the Brazilian colleague, you saw at a certain point a very big picture also. And yes, and sometimes also in the contemporary art museum, they ask a pre-treatment of the, for example, wooden frame to avoid any kind of contamination of the collection of the museum with for example, frame used in the art show and so on.
Yeah, we are not used to think about the possibility that one piece can contaminate the other and so cause other problems.
But it occurs, yes.
Okay, thank you very much. Of course, if someone have other curiosity, can write me and I can share the question with you. And
of course, if you want,
answer or also references to papers or website where find other information. I would like to thank you, Alessia, once again for this very nice and interesting talks, and all of you for the time that you spent with us. So thank you very much.
Thank you.
Let me wish you for someone a Merry Christmas, and for all, I think, a very happy and fruitful New Year.
Thank you.
Thank you very much.
Thank you.
Thank you.